Now, without further ado, I would like to introduce to you the speaker for today. We have Mrs. Smita Tripathi with us, who's a remedial therapist and a special education consultant. Ma'am has over 15 years of experience in skill development and teacher training programs in mainstream schools and therapy centers. She tries to orient parents, school administrators, and teachers to promote or enhance the acceptance of children with special needs in an inclusive school through her training and coaching practices. Ma'am has extensive experience in classroom administration, planning, and implementing of student support service projects in schools. It's a pleasure to have you here with us, ma'am. Before
Thank you, Shivani.
Yes, most welcome. Before I hand over to ma'am, I would like to inform you all that the session is for 2 hours. And once the speaker sharing starts, we would be switching the chat settings to hosts and panelists. Wishing you all a very happy learning. Over to you, Smita, ma'am.
Thanks a lot, Shivani. Like I always say, it's always a pleasure to be on this beautiful platform created by Team Ability. So without wasting any time further, let me start the webinar for today. All right. So today's webinar is about developing arithmetic skills in children with special needs. Before we begin, let's take a quick recap of the previous webinar. The previous webinar gave us an insight into math and its importance. It helped us understand what math readiness skills are, how important they are when you're teaching a child math later in life. It also helped us see what challenges children with special needs face in developing math readiness skills. And it gave us a lot of strategies and techniques that we could use to improve math readiness in children. In today's webinar, what we'll see is how arithmetic skills of addition and subtraction are important. We will look into what prerequisites are, what concepts go into prerequisites for teaching addition and subtraction to children. We will also discuss challenges that children with special needs face while learning addition and subtraction. And also, we will see a lot of techniques and strategies today that definitely can be used while teaching addition and subtraction to children with special needs. So let's begin by understanding what number sense is and how important it is for learning math. Maths is a highly abstract subject, and we all know how difficult it gets if a child with special needs had to actually understand concepts like place value, digits, which make a number of numbers. They have geometry, they have algebra, they have equations, formulas, and many more things. So basically, number sense is nothing but a person's ability to understand, relate, and connect with numbers. In a way, number sense sets foundation for all kind of math comprehension and ability. To make it simple, can I request the audience here, the participants today, to type in the chat box if they are aware what concepts go into number sense. I'm sure from the previous webinar, we discussed this at length. So can I have some of you who can actually help me revise the concepts that go into number sense?
They say sequence, identification.
Sequencing numbers, yes, identification of numbers, they should be.
Patterns, counting.
Perfect.
Ascending and descending order.
Excellent.
Patterns, relationship.
Yes.
Series and less than and greater than, missing numbers, object and number, matching, missing numbers.
That's beautiful. That's beautiful, Shivani. Yes.
And
so
there are few coming. Number position, understanding what the number means.
Okay.
Comparison between the numbers, forward and backward counting.
I'm totally, good. This is like exactly what number sense is all about. And your audience have done a great job. So if a child, we'll see, has good number sense, we can make out this because the child will be able to relate numbers to real life. So in day-to-day life, they'll be able to use numbers. they can visualize and talk comfortably about numbers. So be it any topic, any general topic, subjects, they won't get scared of numbers, and they'll be in a very comfortable position to handle number. They can also easily take apart numbers and put them back together. In a way, they can manipulate numbers just like that. So it isn't a task for them. They can also compute mentally. If this is compared with children who have poor number sense, you'll see that children with poor number sense find numbers difficult, especially as and when the numbers are more, they get very difficult to handle. In higher grades, it's even worse. So from my experience, I'll share that in the classroom, most of the time, what's seen is that children with poor number sense, basically the knowledge gap that's seen in math between the children in a particular grade is because of poor number sense. So the takeaway here for all of us is that number sense is not something that comes naturally. In some cases with practice, it may, but most of the children need a lot of practice with number sense. So all the concepts that we just discussed that you all typed in the chat box today, like counting numbers, rote counting, skip counting, odd numbers, even numbers, forward counting, backward counting, understanding pattern, less than, greater than, all these concepts need to be actually practiced and taught well. The good news here is that if teachers use the right technique, they use the right instruction and use the right curriculum, number sense is just not difficult. It can be easily taught to a child. So let's understand what arithmetic skills go as foundational math skills. So fundamental math usually explores the fundamental concepts in math. So the skills that we are talking about, the concepts that we are talking about as a part of fundamental math are whole number counting and cardinality, counting objects, rote counting, number sense of quantity, like understanding numbers, forward and backward counting, the ability to count forward and backward, or maybe count in twos, fives, and any other multiple, place value, understanding what it means, composition and decomposition of numbers. So they should have an idea of how in different ways can they make a number. So what different combinations can go in together to make a number. Application of mathematical foundation skills within problem solving. So not just understanding the math concepts, but also being able to apply them when it comes to problem solving. And the basic 4 operations that go as the foundational math are addition, subtraction, multiplication, and division. Once we understand this, I'm sure all of us will agree here that no matter what your age, math skills, the arithmetic skills are always and will be a part of our life. Let's see how. So if you have to talk about real life applications, math is a part of budgeting, not just for us, even for children, like their pocket money, or if they have to, buy chocolates, if to distribute in the class, they need to know how much their favorite toy comes for. So understanding of math is a must here. While even playing computer games or learning apps, using learning apps on computers, or even while watching television, math definitely is, somewhere that needs to be dealt with. So the child will have to have basic math knowledge here. Even while learning music or doing dance, the rhythm, the step count, understanding the chords, math comes in picture here again. While driving, calculating distance, knowing the average, deciding on the start time, how long will you take to reach, even while planning their journey to school or coming back home, a little bit of math is needed here again. While shopping, to take advantage of the deals or the offers in a store, or even for basic shopping, a child needs to know some bit of math. Math is also seen in games and sports, to know the average, to know who won, to calculate the scores while you're playing a board game or so. Math is a part of all the subjects that we do today. Most of the subjects, like we have, the child has to know a bit of math there too. Cooking is another thing which is a lot of proportion. It is a thing to do with ratio and proportion. So a bit of math goes in there too, even while exercising, or even time management when it comes to multitasking, knowing what to do when, planning your day, planning your schedule, activity, all needs a bit of math. So no debate on that. We see glimpses of math in all our lives. Whatever our age, we are a toddler, infant, or even an adult, we see maths, we deal with maths. So let's here understand also what researchers have to say about brain and math skill development. According to a study at Stanford University, it's been determined that there is a direct correlation between early math and cognitive development in children. Math also requires one to think critical thinking, concrete and abstract thinking. So because of this, what happens is it leads to these kind of thinking leads to development of brain muscles. Also, it's seen that learning math becomes a springboard to increasing a child's overall intelligence. And with that, math can also be an indicator. So basically, it can predict a child's later reading ability, general education skills, and social progress in their life. Math also enhances analytical and problem-solving skills in children. So yes, there is definitely a direct correlation between early math and cognitive development in children. So the takeaway again here is that we shouldn't waste any amount of time. The preschool years, the age until 5, 6 is an important age for brain development, and math definitely leads to better brain development. So math needs to be taught at the right time when the child is young. Addition for a child is finding the total or sum by combining two or more numbers together. So now here, what we need to understand is while you're teaching, of course, the definition comes later by action, by, using manipulatives, we need to make a child understand quantification needs to happen in the brain of the child. So we will teach addition through activities. All you need to remember here is that you make sure you use these terms which are important, like the digits that are being added are called as the addend, and the sum or the result is called as the total. Also, subtraction is taking away number from taking one number away from the another is called subtraction. So definition is not something which is here, which is important here. What we need to understand is a child needs to understand how does a subtraction equation looks like, what does an addition equation looks like. And coming here again to subtraction, they need to understand these terms. The terminology here needs to be taught to the child. So keep repeating it while you're doing even simple, even preschool levels, while you're doing addition, maybe just counting, or you giving them 1 and 1, C becomes 2. Even when you're giving them simple examples, make sure that you use these terms like we just added, we subtracted. The bigger number here from where we take away is called as the minuend, and the smaller number is called as the subtrahend, and the result is called as the difference. So put across this, the child takes time. What I'm trying to tell you is that addition and subtraction is important because these are the first math operations that a child learns. And like any other first step, this is definitely difficult for the child as well as the teacher and the parent. So it's difficult both the ways. Go slow, there'll be a lot of failures, no problem, but make sure that you use good techniques, you use multiple teaching aids so that the child gets the concept straight and they get the idea of what actually the concepts do, what they talk about. Also, it's important to remember that learning to add and subtract typically happens in small steps between kindergarten and the 4th grade. So you need to plan your addition and subtraction problems in a way wherein what needs to be given to a child when. So once we've understood that, let's go ahead and understand what are the challenges that are faced by children with special needs while they're trying to learn addition and subtraction. You all as educators and some of the parents here must have seen your child facing these difficulties. Remember, the difficulties there's no set difficulty that if a child has, there's no set pattern that, yeah, all these difficulties will be seen in children. It totally depends on the child. It's every child is different here. So all we trying to do here is that understand what are the red flags. Once you've understood the red flags, just keep a note of this. So let's go through the red flags first. Okay, so children with special needs have difficulty comparing numbers. So when we say comparing numbers, addition and subtraction, they don't understand which one is the bigger number. They're not able to make out if the answer like in addition should be bigger than the addends themselves. Okay, so they have a difficulty in comparing which one is a big number, which one is small. they struggle with calculation. So even simple calculations, like, they may have difficulty. They get confused with mathematical symbols. So here, even a simple plus, minus, multiplication, or division is difficult. So the association, as in what symbol does what, the steps, they may not recollect. They may have difficulty in learning that. They have trouble understanding the math language. So math is a language in itself, like we've discussed before. For me, if I have to give you all an example, it's an analogy. So the numbers here are the nouns and the symbols here are the action words. So math is about syntax. What word goes where with what symbol makes altogether a different meaning. So the language becomes a task for children with special needs. Sometimes they even have difficulty with number sequencing. So they omit numbers, they repeat numbers while they're trying to count. Like we see the example here, 1, 2, 3, 3, 5, 6, 8. So they skip numbers, they've repeated numbers, and all of these. They fail to generalize simple concepts. For example, 2 plus 6 is equal to 8. So 20 plus 60 is 80. So this is just one example of generalization. Math has a lot of places where we generalize concepts. It becomes difficult for them to understand and apply these generalizations. Transpose or reverse numbers is something that will be seen often. So 49 becomes 94. They reverse the number. 248 becomes 428, or maybe 842. So it depends on, you'll see such errors. Write number upside down or mirror image. Here, let me draw. So sometimes you will see a child, instead of 3, may write this, a 7 sometimes is written like this. So you will see a lot of mirror image. This is one of the red flag. Okay. So yes, keep track of these signs if you see in the child. Also, the other difficulties that you'll see, now this is mostly seen in higher grades. Children have difficulty with concepts of carrying over and borrowing. So while regrouping, they definitely find it very difficult. What kind of difficulty we'll be discussing in detail later when we're learning how to teach them regrouping. They have difficulty understanding decimals and numeric series. They also have difficulty when you dictate or speak, when a math problem is read. So especially children with language difficulties find it difficult, and even sometimes children with other difficulties. Because this takes a lot of processing, you're expecting them to hear, you're expecting them to break the information in the mind and perceive and understand what, action needs to be taken and how would you solve. So definitely when you dictate or read, it becomes very difficult for a child with difficulties to understand this. They face anxiety while performing math tasks because of failures, because of pressure, because of, poor IQ and cognitive skills. Sometimes they find it really difficult and they are anxious about math as a subject. With all these red flags, one needs to remember that never rule out the duration. Sometimes when you begin teaching numbers, when you just begin teaching them, how to write numbers, children, all the children, even children without any difficulty tend to write numbers, mirror image of the number. They tend to skip while they're counting. So you have to be sure that, for how long the child is doing that after good amount of exposure. So timelines really matter here. Along with timelines, you will also rule out other reasons that can be behind the math difficulty. Sometimes it's poor curriculum, sometimes poor teaching. The child may be new to the curriculum. There's a gap in the curriculum because the child has just changed school, absenteeism. So these can also be reasons for these red flags. So before you make a reference, before you think the child needs any form of assessment, go through your, make sure that your observations are correct. So now that we know what challenges children with special needs face while learning addition and subtraction, let's understand, before we teach them addition and subtraction, what should be the base? What concepts do we need to teach them, prep them with, so that addition and subtraction becomes easy for them? right? So again, audience participants here, can you come up with certain concepts that you are aware of that should go as teaching, pre-teaching technique, pre-teaching skills? As in, before you teach addition and subtraction, what should be the skills that you should teach a child? Let's wait and see what audience have to say.
Introduction to numbers, begin small, counting, finger counting, skip counting, more and less, numbers, number concept, backward counting, putting together, place value, ratio,
Wonderful.
pattern, sequencing, comparison, object counting, time telling, units and tens, bigger or smaller, identification of numbers, the concept of more and less, counting,
Oh,
ascending and descending, teach with
that's too.
object, and number line, patterns.
Okay, some of you have also listed strategies here. Some of you have given the concepts right. In fact, most of the concepts you already are typed and read by Shivani here. Thank you, Shivani. So yes, this is the summary of what we just discussed. So the prerequisites will be rote counting, number recognition, number and object association while they're counting. Counting one more, one less, because that's needed while you borrow, while you regroup. Skip counting, counting by 1, 2, 5s and 10s, understanding of place value, adding numbers up to sum of 10. So basic addition is something that if they're aware of, and then adding 10 to numbers. So if not the last two, yes, but the others need to go as prerequisites because that makes addition easy and subtraction easy for them. It saves a lot of time later when you are in the particular concept and teaching them. So this base building is going to happen around pre-primary and kindergarten. And we begin with addition, formal addition and subtraction when they are in grade 1. So let's understand, coming to the main topic now, what are the different strategies and techniques that we can use to teach addition and subtraction. So now before we understand, we see the strategies, we need to believe that yes, strategies work, techniques work. Now, why am I insisting on this here? Because like any other educator in the beginning of my career too, there was a time when I would think that practice and by memorizing, the child should be able to learn math. And yes, some children, very few children did. But later, what made me, what I realized and what research and studies have to say is that most of the children need strategies. They need to be aware of math facts. So math fact frequency is something that we need to build. So these fact frequencies are basically equations that quick equations that can go into memory, that can be recalled while solving addition and subtraction. So when a child is familiar and automatically can recollect those, facts, math facts that I'm talking about here, the child can actually, the space of the working memory of the child's mind is vacated because the child, for example, 1 plus 0, any number plus 0 is the same number, right? So this is one math fact. If a child is aware of this fact, the child will not waste time in calculating this. The space in the working memory is saved for something more complex. The child can devote that working memory space because we need space in the memory, right? Working memory is like a board, a chalkboard where we do a lot of calculation, mental calculation. So that is vacated for something more complex. So, and strategies, like I said, once you're aware of strategies and you can recollect them and you can use them, the child has this confidence and they start solving math really well. We'll stress on this again when we are doing the strategies and techniques. So first we'll begin with how do we teach math fact fluency to children. So step 1 is to teach them decompose and compose numbers. So basically decompose and compose is different ways in which they can make a number. If you all see the example here, number 7 can be made in these many ways: 7 plus 0, 6 plus 1, 5 plus 2, 4 plus 3, the inverse 3 plus 4, 2 plus 5, 1 plus 6, and 0 plus 7. So if a child is aware of this, it makes it simple. The child will be able to, the child will be able to actually use this while addition and subtraction. Coming to step 2, work with fact family. So fact family here, if you see, is a group of math facts or equations. Like I said, it is created using the same set of numbers. To make it even more simple, while teaching addition and subtraction. The fact families, we need to understand that there are 4 addition and subtraction sentences created using 3 numbers. For example, we're talking about the number 11, 8, and 3 here. So the equations will be like 8 plus 5 is 13, 5 plus 8 is 13. So if you know 5 plus 8 is 13, you also know if you know 8 plus 5 is 13, you also know 5 plus 8 is 13. Along with that, you also know 13 minus 5 will give you 8 and 13 minus 8 will give you 5. This definitely comes with practice. It may be too much for you all to hear right now, but once a child is aware of one, two, the other two naturally comes to the child. So the child should be aware of these equations, ready to use, and they should know that, yes, while doing addition and subtraction, if you're dealing with this number, 3 numbers together can make 4 equations. So these are fact families. While you're teaching them, you can also use these colorful counters wherein these are 8, these are 3, and together they make 11. And a whole part that we discussed in our previous webinar too, we'll again be discussing it today. A tool like this, a teaching aid like this really helps. Step 3 will be teaching them addition and subtraction facts. We will be discussing a lot of facts now after this slide. So once you've taught them these addition and subtraction facts, the next 3 rules are very basic and that you need to remember. The 4th one, get students talking, say it loud. So this means whenever you're teaching a strategy, when you're talking about a fact, or when you're even doing simple calculations, make sure that you say loudly the math that you're doing, okay, needs to be. So don't just solve it. Don't just do it on paper or the board, or like even while manipulating, objects, don't just do it. Say, okay, so here I picked 2 dolls and here another 2. So in this we have 1 and 2, we added 2 more. So when you do that, when you talk what you're saying, what you're doing, the child indirectly is trying to learn from the child in future is going to model. So when a child is asked to solve something like that, the child is going to use the same, recollect what you did, and it makes it easy, not just saying, by also listening to what you're saying. So while you're teaching, your actions should always have a talk attached to them. So basically say it loud. Whatever is your math thinking in your mind needs to be told. Also, remember to practice daily. So whenever you're doing a new concept, revision and daily practice is something that we shouldn't forget, especially for children with special needs. In fact, for all the children, because math is something that practice makes you perfect. So you need to practice. And along with that, use beautiful activities, engaging activities. So children with special needs have variety of difficulty. With that, they have different strength. So when you use engaging activities, when you try and wake senses, different senses, their hearing skill, their visual skills, their, mnemonic. So basically, if you try and use VAKT methods, visual, tactile, kinesthetic, and audio methods, all the children benefit. So with this, we move on to strategies. Horizontal addition is one of the oldest mental math strategy. So what happens here is the numbers are placed one close next to each other. So one number goes in mind and then the other number is added. This is a later stage, but here, like I said, you can even begin these activities with just placing 2 objects next to each other. And then slowly from manipulatives, you can move on to placing 2 pictures next to each other, and then moving on to dice, worksheets, and other interesting teaching aids if you all can make. From horizontal, this is a way we need to make this image clear to the child that yes, even an equation like this is addition. Once you've done that, you will go on and help a child even build this image that yes, vertical addition looks like this. So you have numbers above and below, they are placed. It's as per place value, and to make it interesting and to make it natural. Like, see, this is a technique wherein the numbers are put in a tunnel. So we know it goes down. So above and below, the child understands that, okay, yes, addition, you can even add numbers up and below. Transition can also be done like this, wherein you have dice placed above and below and expect the child to write the numbers here and then do the addition. So this was basic introduction to horizontal and vertical addition. Yes, with 2-digit numbers and 3-digit numbers, we definitely stick to vertical addition. That's what is expected. activities that we can use to teach addition will be, so we will be seeing a lot of activities. You all can make note of it, come back to it later. Together, when you look, when you'll try and see these activities, they may be too much, but trust me, we cannot say which activity will work with which child. So have kind of understand what are the activities that we can use and later use it as per the need and the comfort of the child. So coming to the first one is manipulatives. Now, whoever wants to kind of, get into addition, always remember, never begin with worksheets, never begin with doing addition on the blackboard, the whiteboard, or on paper. Addition should always begin with manipulatives. Manipulatives are, objects that are readily available, easily available in the classroom, in the house, and even better if these are objects that child sees and deals, the child gets to deal with it on a daily basis. So it can be fruits, vegetables, beads, grains, counters, Legos, and their own, toys, the pegs that we see here. So anything can go as an manipulator. So once you're doing this, the first thing is counting all. So we begin with teaching them how to count all the objects that they see. So you actually have to start counting with them, like, it's more of modeling how to count. So you will maybe begin with giving them, say, three candies, and then you'll add two more and then say, yes, let's count. So it's 1, 2, 3. The image here talks about two different color candies, but it's safer to begin with similar objects. So when I say same, it needs to be same in color, size, so that the children don't get distracted because of the shape, size, or color, or anything else. For example, if you're using pens, don't use different color pens, maybe pens that look similar, which are same. So use the pens and begin with that. So once the child is comfortable counting, has understood the concept, then maybe you can move on to, where you think the child has mastered the process of addition, not just the answer. Then you can introduce objects which look similar, and then maybe which are same, different objects, like if we add even apples and bananas, for example, right? So though they are in the category fruit, we can begin with apple and then maybe move on to the other fruits. Just an example here. And then you can use their own Legos, which makes it interesting for them. This is a DIY wherein adding machine an adding peg hanger is made. So the children put the pegs, and maybe you can put the peg, and they have to count how many and then write together. Even dice can go as your teaching aid. So with dice, and later the child even begins subitizing. So like they don't have to count the number. They can just say and see, yeah, this is 3, this is 4. So 4 plus 3, 4, 5, 6, 7, or something like that. Fingers are the most natural technique or supportive method that children use. So counting on fingers is something which is it comes naturally to children. You can encourage that in the beginning. Tally marks are again very important tool that can go. Doodling or drawing, making dots. And yeah, there's another interesting example here wherein we've made an adding machine. So you drop two different things. So basically 2 things from here and maybe 1 from here, and together you'll see that, yeah, they are together. These many, you've added them, and now this is the result, the sum. So never underestimate manipulatives. It's a request. Always begin with manipulatives. The children have to feel what actually goes into addition, how it feels to take away, what's adding on. So experience is something which is important here. Once you've done that, the child has understood the concept. Slowly, the transition to visuals can take place. So here, the child will get, the images. Even better if you can write numbers next to images, because this leads to association that, yes, 2 is equal to these 2 objects and 3 looks like, these 3 objects. So writing number next to the image or the visual is really important. You can even ask children to draw later. So the children can draw themselves the number and they can count. Also, remember, while you doing visuals, the worksheets need to be planned. The size of the drawing, the amount of images that you put in the worksheet, all depends on the child. So the difficulty level should be decided, keeping the child's skills, the abilities of the child. From that, we will move on to the next, which is using the number line. Now, this is a beautiful aid that helps teaching addition. So the first thing here will be introducing the child to the number line. So basically, they should get hang of what does a number line look like. Okay, so why number line here makes addition easier? Because see, until now they had to count all the both the numbers in addition. They had to count all the objects maybe while they were adding with manipulatives. But number line makes it easier because you can just begin with the first number here on the number line and then two more. So you can count two more and you can reach the answer. So it takes away the need to count both the numbers. So the first number can be directly looked on, and then the next number can be skipped. You can actually count on and reach to the answer. So get them used to the number line. So here you can ask them questions like, where is the grasshopper? They need to say, yes, it's on number 7. So accordingly, you can use your image, keeping the child's interest. Everything here depends on the child's interest and ability. So never neglect that, okay? You may not like this insect, but maybe it's the child's favorite. So yes, you have to use that. Bring in the child's interest. This will make less distraction for the child. The child will focus on your activity. The next way is that you can even put missing numbers in the number line and see if the child understands that yes, number line goes in a certain pattern, in a fashion. So they know if you're skip counting, like here you have a 2's number line, so 2, 4, 6, 8, and so on. Or maybe they can fill this, like they can put 1, they can put 3 here. So what's gone missing, they have to recollect. So here counting on is important. Recollecting, counting, rote counting, they'll bank on all the preconcepts that you've taught them, use here. Okay, you can even introduce number line and then make it interesting for them with a Lego or a block set like this here. So they know it's moving forward. Okay, so when you're on a number line, you're moving forward while you adding. Later, once the child is understood, you have to together do it, like move your hands on the number line, make sure that you're holding child's hand and helping them count on the number line. Once you've reached that stage wherein the child is independent and the child can count all by themselves, move on to worksheets and give them and see if they can practice using number lines for addition. Once number line is taught and the child has learned counting on, you would want the child to continue counting on in their mind. So how do you do that? Maybe once the child has understood the concept of counting on, like say 4, after 4, 5, 6. So this concept through number line is already there in the child's mind, okay? So you can begin slowly by taking away the number line and maybe like we see an example here, introduce the number 6 is here, give 2 tokens, counters, ask the child to count how many now. So 6 plus 1 and 2, that makes it to 8. So you can write the equation for the child if you think the child is unable to write now at this stage, or if the child is able to, let the child write. So this way you can actually make sure that the child does continue counting on. Ideally, the thing is eventually you have to bring the child to this stage. So for example, let's see what 8 plus 4 is equal to. So when you're doing this in mind with counting on, you have to teach the child the big number goes into your head. So 8 goes into your head plus 4. Now we need to use our fingers. So you will project 4 fingers one by one. And while you're projecting, you will label them. So 9, 10, 11, and 12. Now that you've done that, the last finger gives you the total. So it's not about the number of fingers. It's about what number you've just said. So 8 in the mind, 9, 10, 11, 12. So 12 becomes your answer. Remember, this needs a lot of practice. Sometimes children are not good with, counting on fingers. They may skip a finger. They may repeat a number on their finger. So while you're doing it, model it really well. Go slow. Make sure when you're doing finger counting, there's no other distraction. First, you do it. Then you maybe can do it with the child, as in holds the whole child's hand and do it together. And once you know that, yes, the stage is mastered, then you can move on to letting a child count by themselves. Remember, you don't have to give any kind of prompt here. Only when you know without prompt, like you shouldn't be saying, what more, are you done? Is it done? Is that the answer? So the child should confidently be able to say that, yes, 8 in the mind and 4 in the fingers. So 8, 9, 10, 11, 12. Once you've reached that stage, along with fingers, you can also use tally marks. You can use dots, like I said. You can even doodle. So a child can draw objects and count. So make tally marks for each number, and then how many together. So even this technique, if your child is comfortable with, do it first. So show them that yes, 4 looks like this. See, there's a color thing also here. They've tried differentiated the numbers with colors, and the sum is in a different color. So this, even this simple thing as using different color for different number is a technique that helps children who are visually learning, who are keen towards color, and because this becomes a language for them. They are learning through colors. So then we'll move on to another strategy, another teaching aid that's really interesting, and it's I mean, I'll say it's a must, and it is a beautiful technique that can be used in classroom. It can be used one-on-one on the board with children while you're teaching them to add. So it's called as the tens frame. A tens frame looks like this. Now, before you can use tens frame, the first thing that you need to do is that you need to teach them how to draw a tens frame. So here, if you see, there are 6 lines, vertical lines, and then draw 3 lines across, top, bottom, and middle. So once they've done this, yes, the number frame is ready. Now, how do we use number frame, a tens frame, I'm sorry, to add? The example that we see here is 7 plus 4. So once you draw a tens frame, you put the first number. So say we are making circles here, 7 dark circles. So we've put 7 dark circles. So these circles represent number 7 in the tens frame. Then we have 4. So we add 4 more circles. So maybe these are different circles, as in we're just making light circles here to show that we've added 4 different circles here. Now together, how many tens? A tens frame, basically, like we've discussed in our previous webinar, a tens frame represents number 0 to 9, right? So if this entire thing is full, this is 1 tens. Okay, and this is 3 ones. So unless and until the entire frame is full, we've not reached tens. So in this case, we have 7, 8, 9, 10, one entire frame. So that's how many tens? 1. And there's one single circle left. That's how many ones? 1. So when you add these together, what is the answer? 11 is the answer. So this can even go as an anchor chart in the math wall if you have in your class, or make one in your class and put this. So referring to this is important while a child is learning these kind of visual prompts, okay, or maybe your verbal prompts. Really help. Never, explain it once and assume that the child is going to use it. It's simple. They definitely need visual clues. They need verbal clues. So give them the kind of clues, handhold in the beginning when they are learning to use a tens frame. Another example here, 8 plus 5 with color coding. So 8 goes as blue counters, 5 goes as green counters. You will see this particular frame is full. So this makes it 10. So 1 tens and 3 ones. So the answer is 13. This example now here shows an interesting child-friendly way, as in a child is interested in monsters. So this is the number of teeth here. So 7 plus 1. So 7 orange, 1 green, and together they need to guess which is the answer. I'm sorry, not guess, count. So 1, 2, 3, 4, 5, 6, 7, 8. So among these, this is the answer. Now a tens frame. So one important takeaway here, okay, it's something that we need to remember is that whenever you're teaching them numbers more than 10, like 11, 12, it's not 1, 1, 11, 1, 2, 12, 1, 3, 13. It is always 10, okay, 1, 10. So 10 and 1 is 11, 10 and 2 is 12. So this gives the base for place value. It helps them understand that yes, 10 ones together will make 110. Another example here. Now, this is an example wherein how can tens frame used for word problems. Maybe the word problem is about chocolate chip cookies and oatmeal cookies. So you have 9 chocolate chip cookies, 6 oatmeal cookies. So how many are they together? So here, okay, let's see the tens frame first. So 9 chocolate chip cookies you've drawn here, you've put them in the box, then 6 oatmeal cookies. So it's 1, 2, 3, 4, 5, 6. So this tens frame shows that yes, the answer is 1 and you have 5, 15. Okay, what is done here is number bond. We look into it while we're doing number bonds later. So this is tens frame. It's an handy tool. Keep it in the class. Teach your children to make their tens frame and use it because it becomes really easy when they're learning addition. Other than tally marks and manipulatives and drawings, tens frame can also be used. Number bonds, like I said, number bonds is another simple technique. A number bond is a relationship between a number and its parts. Trust me, we knowing or unknowingly use number bonds many times. Maybe I can highlight today while I'm teaching that how we use number bonds ourselves while we doing addition and subtraction mentally. Okay, so for children to understand, oh, this is how a number bonds looks like. 8. So what makes 8? 3 and 5. So these are parts. This is the whole. So when you want to introduce the concept of part and whole to them, you can maybe begin with something as simple as this: pictures. So this is an entire orange, maybe one slice of orange. Maybe this is the entire packet of chips, the whole packet of chips. This is just one part. Okay. Pizza, the entire pizza, and maybe just one slice. This is one part of the pizza. Same goes with watermelons and other examples. So you can introduce them to the concept. They should know. So like I said, the mental image of what does a whole look like, what does a part look like in general, not to do with numbers. Once they understand, yes, take them to number bonds and help them understand that 8 can be made when 5 and 3 come together. So this is the biggest number and these are the small ones. Here is an example, 7 plus 4. Now, why number bonds also help you learn math facts like we discussed before uh, while in the beginning. So 7, 4 and 3. So if they know that 3 plus 4 is 7, okay, they also know 4 plus 3 is 7. So this comes with practice, like I said. 7. So if you know you have 7 and you have to take away 3, the answer is 4. Same as 7 minus 4 is equal to 3. So this gives them a hand. This is the math fact. Once the child is mastered, so if they know this, they can easily remember the other 3. It's like buy one, get 3. So teach them this and they'll be able to put the others in the equation. This comes with practice, I'm saying again. Now here is an example of how do we use number bonds. So if you're trying to add 16 plus 8, okay, in your mind, I'm saying, not on the paper. Yeah, you can also do it on paper, but most of us, when you're doing it fast, you know in your mind that 8 is nothing but 4 plus 4. So 16 plus 4, now that makes it easy. Maybe we recollect that 16 plus 4 will make it 20 and 20 plus 4 is another, it's 24. Instead of directly adding 16 plus 8, wherein maybe this is not an equation that you've seen that often, but yes, making 10s, 20s, 30s, 40s, it is something that comes easily, even when you're doing multiplication, multiple tables, timetables, you would know that there are certain factors that you recollect easily and certain take time. So maybe this is one of the factor that you can easily recollect, that yes, 16 plus 4 is 20 and 20 plus 4 is 24. Just an example of how number bonds go and how we can use them. These are interesting ways of introducing a child to number bonds. So here is a plate with partition. So these are parts and together will be whole. Same thing, Lego, with these dominoes, that 5 and 2 together will make it 7. So the whole is 7. The parts are these. Again, pegs and hangers can be used to teach the children number bonds. This is an interesting game. Now here you have, so you can have children given these cards wherein sometimes the part is missing, sometimes the whole is missing. So you can maybe ask the child, where's I have the parts, okay, so who has the whole? The child should be able to calculate or should know that yes, 10 plus 6 is 16. So 16 is something that we are looking for. Here, you know that this is 9 and this is 2. So they should be able to calculate, okay, 9 minus 2 is 5. So 5 is what they are looking for, what you're looking for. So these are various games. Later, when you finish teaching them addition up to 20 or 10 and moving ahead, you know, when you're doing, you can bring in number bonds and make addition a little easier for them. So another example, how number bonds are used: 34 plus 28. So 28 is close to 30 and 30 is made up of, say, 28. So already we know, so 2 more will make it 30. So 34, instead of 28, you'll add 30, which gives you 64. 64 minus 2 will give you 62. I'm sorry, this may sound too much because here we are talking about basic addition and subtraction. But yes, on later stage, you will see how compensating numbers, using a different number instead of the number that's given, and using number bonds like these, so these becomes your multiple strategies or techniques that you're using to add. Okay, so after that, drawing models. Now, this becomes very important because it is a bit structured. It is like a schema, a drawing, a schema that can be readily used to understand word problems. So actually, bar models or drawing models, as they called as, they can be used to understand word problems. It makes understanding word problems a bit easier. Here's an example. Let's see. Mrs. Garcia sold 2,150 apples on Saturday. She sold 527 fewer apples on Sunday than on Saturday. How many apples did she sell on both the days? So Saturday, the bar, it's a bar diagram will give you an idea that this much, too much, these many apples were sold on Saturday, whereas these fewer apples, okay, so together is 2,150, whereas these many lesser apples were sold on Sunday. So what should be the rest? So this diagram helps you understand that out of these, you know this number and you need to find out this number. You can also try this with simpler problems. Now, this is an advanced problem. I wouldn't suggest something like this right in the beginning, but your simple problems like you have 4 birds, and out of 7, 4 are left. So how many flew away, something like that. So make it easy. Help them understand that the bar diagrams can also be done vertically, can be done horizontally, and it in a way will show you, give you an image like this. Make it interesting. You can use their Legos. For example, 4, you can use these here, 3, and then together, how many? So this again is a part of bar diagram. See, you've made whole, you've made part. So if part and part is this, what is whole? Or you give them whole and one part and expect them to answer the other part. So drawing models look like these and can be readily used. The next thing here is using expanded form. Now, this is a beautiful aid, especially when you're teaching place value. If a child is aware of place value, okay, you can go ahead and teach addition this way. So instead of expecting them to actually add, for example, your 43 plus 24 and make it difficult for them, you can model this in a using expanded form. So draw tens and ones to help add. So 24 has 4 ones and 2 tens. So now this is based on base 10 blocks. If you all remember in our previous webinar, we discussed base 10 blocks in detail. So base 10 blocks have units. So this, okay, a cube like this, a unit which represent 1, a rod which represents 10, hundreds are represented by flat. Okay, we see here, yes, hundreds are represented as flats as these, and then you have cubes as thousands. Okay, that's a later stage. So if a child is aware that ones is here, tens look like this and hundreds, so this gives them how big a number looks like. So these are readily available tools. Again, you can directly order them and use them. Using base 10 blocks for teaching them place value is a beautiful aid. Like I said, place value is an abstract concept. Only when you give it something concrete, use concrete material like this, the children will be able to understand. So coming back to this example, if it's 24, 4 ones they've done, 2 they represent, they know 2 is 10, so rods will represent 2. Again, 43, 3 ones, 3 units, and 4 tens, so 4 rods here. So together, answer is 1, 2, 3, 4, 5, 6, 7. 7 ones and 1, 2, 3, 4, 5, 6. 6 tens and 7 ones. So 67. Likewise, you can also use, put them in the place value boxes like these. So 24 plus 2 can be visually, this is a clue. So based on blocks method, so you'll put 4 ones here because 24 has 4 ones, then 2, so 2 ones here, then 20, so 20 again 2 rods here, which represent 2 tens, and then you will add. So these are together 6 ones, and this together is 2 tens. So 26 is the answer. Coming to this particular example, break it down. Now, once the child is pretty comfortable with this and child has outgrown, as in learned and mastered this, you can slowly move the child to breaking it down. This is another technique which you can use, and it really works with children. Instead of 49 plus 34, mental math trick again, add the tens and add the ones. So here 40 and 9, you've teach them to break it down. And this is 30 plus 4. So 40 plus 30 is 70, and 9 plus 4 is 13. So together it's 83. So these are strategies. You break number apart, you expand, and then you add, and then you put the tens and ones together. Another example here, which also has hundreds. Now here, this is basically regrouping. So like I said, when you're teaching them addition, and regrouping is involved. Now when they know 4 ones is 4, and then here tens, it's more than 10, it's 12. So you have to, 10 tens will make 100. So you've given 1 to the hundreds column. So visually seeing it and then learning it makes a big difference. Now, these are certain tricks, math facts that we were talking about. If the children remember, this gives them brain breaks. Now, what are brain breaks? Brain breaks are basically tricks or facts basically that if you are able to remember and recollect, it gives your brain break from calculating. That's why we call it brain breaks. Okay, so your mind you won't use the space in your memory to calculate, because of which your memory is going to be useful, or you'll use your memory for other calculation that you have to do. So these are simple. So partners of 10. Okay. So what makes 10? 1 plus 9 will make 10. 4 plus 6 can also make 10. 8 plus 2 can also make 10. 2 plus 8 can also make 10. 5 and 5 together is 10. 7 and 3 together is 10. 3 and 7 together is 10. 9 plus 1 is 10. 6 plus 4 is 10. How can you help child memorize this? The partners of 10. Okay. Children with good memory, you should definitely try this. Teach them this, and even children with poor memory at least will be able to remember few of these. So if they remember few, at least they'll have fewer brain breaks, which is really important while you're handling too many numbers and doing too many calculation. So this is one beautiful technique wherein you've made a teaching aid which looks like a rainbow. So the rainbow here, the yellow, for example, the yellow at this end and the other end. So this end has 2 and this end has what will be here. So it's something that the child will guess and then flip and see if they are right. So if it's 4 here, what should come here? It should be 6. That will complete and make it 10. Like that, if it's 1 here, what should be the other number on the other side of the rainbow? Yes, it's 9. So 9 and 1 together will make it 10. You can also have a cloud kind of a thing made here, which has the strips here, which again, so the more they see, the more they remember. It goes as a picture memory in their mind, and they'll be able to recollect. For teachers who've just started teaching and have never tried math tricks and techniques and strategies, you may find that is it really possible to do all of these? But trust me, when you're teaching, when you've got the hang of it, when you use these strategies, you will see that children do tend to remember these tricks. They are good, they are looking, the child's mind is always looking for tricks. And once you give them such facts and as tricks, they are able to put this in the mind and recollect it when they have to. Here's another, number 10 is really important here. So another trick or a technique is make a 10. So 7 plus 4 in your mind, while you kind of calculate, you will first, that if it is 7, another 3 will make it to 10. So 1 is left. The number bond will help you understand that. So another 1 will make it 11. Again, these are all mental math tricks. You will see that more you use it, the more you're comfortable, and you will be able to do it fast. This again, if for example, you have a problem like 9 plus 6, you will know that yes, 9 plus 1 will make it to 10, another 5 left. So that will make it to 15. Now, another technique, now all depends on what works well with your child, is something called as the bridge through 10 technique. So here, if you have an example, you have a number, for example, 9 plus 4, okay? So the minute you see 9 or your child sees 9, the child knows, okay, 9 plus 1 will be 10. Another 3 left, so 10 plus 3 will make it 13. So you split basically 4 into 1. You take away 1 from 4, which makes it to 10. And then the left number, the amount is 3, which you add and you make it to 13. So partners of 10, make a 10, and bridge through 10. These are techniques that can be taught. So the child will be able to remember the facts and recollect them when needed. Compensating is another technique, mental addition strategy here. Compensating is all about taking from one number and giving it to the another number. Doing this can sometimes make an addition easier. to work out in your head. Trust me, you don't have to use all these strategies, only depending on what numbers, okay? Your numbers will tell you what strategies you have to use with practice. For simple addition, one-digit addition, nobody would actually think of compensating because those are mostly facts that you remember. 7 plus 3, 4 plus 6, 2 plus 2. So you will kind of remember. You wouldn't be using these strategies. These strategies come in picture when you're going for bigger numbers. So here's an example, compensating number. Compensation involves deciding which number to adjust to make it easier to add or subtract. Compensate by changing the number by the other number. So what I'm trying to tell you here is that, for example, you have a sum 47 plus 16. So you know 47 plus 3 will give you 50. Another fact that you, like I said, 10s, 20s, 30s, 40s, 50s, you tend to remember them. So 47 plus 3 will give you 50 because you've already added 3 here. You'll take away, you'll subtract 3 from here. So left is 13. So 50 plus 13 will make it 63. Maybe in your mind, you've done 50 plus another 10 is 60. What's left is 3, so 63. So this is compensating numbers. Zero facts can go as beautiful brain breaks. For example, if you're adding any number, okay, any number plus 0 is equal to the same number. Sometimes children don't even remember these facts and they end up wasting or energy, time, and getting confused by adding 0 with numbers. So time and again, we have to use games, tricks, flashcards, or maybe even an anchor chart, which helps them remember this particular rule that any number plus 0 is equal to same number. So now here you have a flashcard, which is more like a bar diagram or a whole part thing. So you've tried asking the child that, yes, if the answer is the whole is 10, one part is 0, what will be the other part? Of course, 0 has no value. So the other part is 10, because of which the whole is 10. Okay, okay, the next one here is monkey in the middle. We all have played this game maybe on a beach or in a ground wherein you stand in the between and there are two teams passing the ball and you're trying to catch the ball, the monkey in the middle, right? So monkey in the middle is a beautiful trick or a strategy that can be taught when children, or used or applied when children are trying to add number in a sequence. So for example, if a number goes missing. So what I'm trying to tell you here is that, for example, you have to add 5 plus 7. Okay, 6 isn't here. 5 plus 7. You know the monkey in the middle is 6. So basically 5, 6, 7 is a sequence. What's missing is 6. So 5 plus 7. How do you do that? Instead of adding actually 5 and 7 together, simplest way to remember is whatever is the number in between, that is double. So 6 plus 6 is 12. Of course, this is a fact that you will teach and the child will recollect. Okay. So instead of adding 5 plus 7, see what's the number which is missing in the sequence and double the number is the answer. Okay. So 6, 5, 4, 5 is missing. So 5 plus 5, 10. So 6 and 4 together is 10. You can actually first use such logs, Legos here to help the child understand. So this was maybe these many, you were adding 8 plus 6. So 7 was missing. So if you give here 1, they become 7. So what was missing in the between was 7. So 7 plus 7 is 12. 14. So here you've done something concrete to help a child understand with these manipulatives that how monkey in the middle works. So here is another example here, 7 plus 9. So maybe this was 9, 8 is missing. You give here 1, this becomes 1 less 8, this becomes 1 more 8. So monkey in the middle, basically between 7 and 9, 8 was missing. 2 times 8 is 16, which is the answer. This strategy is also called as doubles plus 2 strategy. So I know it's a double plus 2 more because the number missing is in a pattern. Like I said, 5 plus 7. Okay, so something is missing, 6. 7 plus 5, something is missing, 6. So I double the smallest number and add 2 more. In this particular strategy, the smallest number is doubled. So 5 plus 5 is 10 plus 2. You have 2, which is 12. Like here, smallest number is the same thing. The smallest number is 5, you double it and add 2. So monkey in the middle, double plus 2 strategy, these can be used for numbers where you have to add and it's a pattern. It's a sequence and one number is missing in between. So with practice, again, if a child sees this kind of problem, they will recollect this strategy, use this technique and give you the answer. Doubles. Now, another math fact, which can go as a brain break, instead of calculating doubles like 4 plus 4, the child has to use fingers, other manipulatives. If the child is in still supportive mode, or later when they are adding numbers directly, if a child remembers, and if you've taught, the double fact, 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, this becomes brain breaks for the children and they can use it by addition and subtraction. These are certain chants you've tried and make it interesting. For example, 8 plus 8 equal to 16. Think of colors like red, blue, green. So they're rhyming, right? The child tends to remember. Make it only if your child has this flair for chants and your child uses this as a technique to learn. Don't introduce this to a child who has difficulty with language, because for them, maybe visually seeing this more often is a technique instead of the chants that they hear. For children who learn through hearing more, you can use chants like these because it becomes a language, a learning medium for them. 5 plus 5 equal to 10. Count all your fingers again. So many examples you will find interesting techniques. If you look for, you will see doubles can also be taught through many more techniques. You can make your own technique too. Near doubles plus 1 is another one technique here, trick. So if you have number, which, for example, 6 plus 7, we know somewhere that 6 plus 6 is 12. So one more will make it to 30. So here you're not wasting time in counting or adding 6 plus 7. You've directly used the technique, you've used the fact that you remember, you've applied it and you've got the answer. Double plus 1. So find the lower numbers, say the double fact and add one more. So 7 plus 6, 6 is the lower number, 6 plus 6 is 12. So add one more, 13. 7 plus 6 is equal to 13. Learning doubles, near doubles. So this become another two fact that you can actually introduce and use with your children. Coming to the next one, teaching them the commutative property, the turnaround fact. Sometimes children, as in you have to actually teach this to the child. The commutative property of addition says that if we add number in any order, okay, it's 1 plus 2, or you add 2 plus 1, the answer is going to be same, 3. Do it and show it, okay? So when I say do it and show it, use manipulatives, show them that this group has 1, this group has 2, together they're 3. Even if the other way, if the other group has 2 and this group has 1, still the answer remains the same. Flip the add-ins and the sum doesn't change. So it's like a logo jingle that you can kind of teach them. You can put it as a flashcard on their study table, or you can put it on the math wall so that they remember this as a fact and they can use it when they are adding. Another interesting way to teach this commutative property of addition to children is when you add, don't go mad. If the numbers turn around, because the sum will stay the same, and that's the name of the turnaround game. So see, it's another interesting story way, or, you kind of have done this small math talk with them, that they are these turnaround friends, so if it's 3 plus 2, the answer is 5. If it's 3, even if it is 2 plus 3, the answer is 5. The sum remains the same, even if they keep turning around. Another turnaround fact, the child should be able to. So here you can highlight, or you can use this to teach them this, wherein 3 plus 6 is 9. So 6 plus 3 is also 9. So all the facts that we were discussing in the beginning, see, so turn around is the trick. So 4 plus 7 is 10. So turn around, 7 plus 4 is 4 plus 7 is 11. So turn around, 7 plus 4 is also 11. 2 plus 8 is 10. So turn around, 8 plus 2 is also 10. So do this number of times, multiple times with your child, unless and until you know that, yes, they understand and they are applying it. They're applying the commutative property while they are adding. The next important property here is the associative property. Here, while adding 3 or more numbers, the sum, okay, is the same no matter whatever is the order of the add-in. So 2 plus 6 plus 4 is 12. Even if it is 6 plus 2 plus 4, the answer is same. Even if it is 4 plus 2 plus 8. So whatever is the order, the numbers, if the numbers are same, the answer has to same, irrespective of in any order that you add them. So here is an example wherein team 1 first scored 5, then they scored 1 plus 4, so which makes it to 5. So 5 plus 5 is the final score. Whereas team 2, maybe in the first round scored 1, later they scored 5 and then 4. So 5 plus 4 is again 9, 9 plus 1 is 10. Eventually both have scored the same because the numbers are same. Very good example here is with blocks. You can start like say 5 blocks, 5 blue blocks, 3 pink blocks, and 4 green blocks. So you asking them just to add the blocks and give you the answer. Irrespective of they add first blue or pink or they add pink and green, the answer remains the same. So what you're looking for is that you need to know how many blocks are there together. This is like, visually when you are shopping or when you go out, you in a parking, you can help them understand that see, there are 4 gray cars and 2 red cars, okay? And 3 blue cars. So you first added maybe 4 + 2 and then 3, the answer is 9. Even the other way, if there was 4 gray, 3 blue, and 2 red, okay, you first have gray cars and then you've added red and blue, still the answer remains the same. So basically, you need to put this across that whatever is the order of the number, the answer remains the same. Do it as many times as you can until you know the child has mastered this particular thing. And while problem solving, the two are not busy looking for which number comes first and which number comes later. Irrespective of the order, they're able to add and give you the answer. Coming to one very interesting strategy that I say we should definitely try and use, especially with children who have autism or children who have language difficulty. And other difficulties also. In fact, touch math is supposed to be, it works really well with all the children in the classroom, if you see. Why touch maths? Now, basically, touch math is where the number themselves become manipulative. So what I'm trying to tell you here is that the number is the manipulative. On every number, you have these touch points that give you the quantity of the number. So 1 has 1 touch point, 2 has 2 touch points, 3 has 3 touch points. So you will slowly introduce the number along with their touch points and see if the child can remember it. So slowly do it. At once, you don't have to introduce all 9 numbers and expect the child to remember. Begin with 3 numbers at a time or 2 numbers. Once you know the child is mastered, the child remembers the touch points of that particular number, move on to adding few more numbers. So 4 has 4 touch points, 5 has 5 touch points. So touch points basically becomes the point that the child will use while they're counting. Okay, I'll get to the how to use it. First, let's finish about the touch points. So number 6 onwards, some of the touch points have 2 touch points. So 6, if you see, it has 2 touch points here, 2 touch points here, and 2 touch points here. So while they're counting, they need to count this twice. 1, 2, 3, 4, 5, and 6. So these are 6 touch points on number 6. 7 again has 1, 2, 3, 4, 5, 6, 7. So 7 touch points. Like that, the child has to get used to first the number. Introduce this through, art and craft trick like this, or maybe you can also buy ready to use touch number manipulative. The idea here is that touch points make it visual, auditory, and even hearing. So basically, the child is seeing the number, the child is saying the touch points, the child hears the the count, and it's a visual VAKT method. The child is getting to do all of these. So once the child is using, for example, if they have to add 2 + 1, so it's 1, 2, and 3. That's the answer. If it is 3 + 2, 1, 2, 3, 4, 5 is the answer. So this is for children who actually want it more, for children who want it to be concrete, who literally want to kind of, add. So you will see that this technique really works well. It can also be done for subtraction, and it can be done for multiplication and division too. There are a lot of videos that you can see, and if you're not aware of, you yourself can learn how to use these touch points and then later use it with your children. With touch points, we've finished the number. We've seen some of the strategies. I'm sure there are many more. If you are aware of, you can use them. If you're not, you can use one of the strategies that you've seen here today. From there, we move on to learning how to do word problems. So with word problems, first thing first, you have to get the child used to the vocab, as in what are the different terms that the can hint or which mean addition, add, more, plus, increase, total, sum, all together. Slowly build this vocab. It cannot be done in one day or in just one class, okay? So slowly build on the addition vocab, introduce them to the symbol of addition. Now here we've tried making it a bit interesting so that the children remember in a story form. So this plus symbol is called as Gus the Plus. He's a generous young man, giving to others whatever he can. He'll show you how many that you have in all. When he comes around, your sum will grow tall. He adds numbers together so that you will have more. With help from Gus, adding is never a chore. Sure. So this can go on the anchor wall, the wall, and the children will be able to actually use this as a hint to recollect that, yes, this means addition, this means sum, this means the value is going to increase. Now, these are certain mnemonics, okay? Sometimes remembering and recollecting the steps while doing word problems is a difficulty. So a mnemonic like this, wherein cubes means circle the key numbers, underline the question word, box the action word, okay, evaluate as in what steps do you take, and then solve and check. So if you put this on a child's table, or if you give this kind of a verbal clue, a hint, the child will be able to recollect, and with practice later this can be weaned off and the child will be able to actually follow the steps as process. This is another method wherein color coding is done. So while reading, you consider, you plan, you write, you solve, and you evaluate. I'll quickly do this with an example. So here there are 6 red socks, one number with one color you've circled, and there are 2 green socks. So another color to circle number 2, and how many socks are there altogether? So see, the technique that's used here is the child has first drawn the picture, 6 red socks plus 2 green socks, which makes it to 8 socks. Another example here is wherein a tens frame is used. The child has put 6 red dots, 2 green dots, and together 6 plus 2 is 8. So we will discuss word problems while we are discussing subtraction, once we've seen the strategies with subtraction too. So this is just to give you an idea that whenever you try and begin word problems, remember to first build the vocab, give them the understanding, do the association of what symbol means what, as in what are they expected to do, get them hang of the process. If it's difficult to remember, give them a mnemonic like this, and then practice through whatever technique they are comfortable, drawing, tens frame, number line, or a bar diagram. Use all those techniques that you've seen for solving word problems and make it more comfortable for the children. So activities to teach subtraction, we'll quickly go through, because now that we've seen addition, it's similar, but yes, I will take you through what can be the strategies that you can use for subtraction. Again, first introduce them to the horizontal method. They should know what does an horizontal equation looks like. So the numbers next to each other, the symbol looks like this, and equal to will give you the answer here. Even when you're doing it with pictures or manipulators, remember, horizontal subtraction is something that a child sees more often on a worksheet, especially in the beginning while learning subtraction. Once you've done that, you will also simultaneously build this vertical subtraction image in the mind of the child. So you will give concrete objects, you will use an interesting aid like this, wherein there is this pipe with beads. Okay, you are 5 together and you've taken 1 away. So what is the answer? You can also do it with images. So move from concrete to images, and then finally to symbol, like we have discussed in the CP approach. So first concrete, then picture, and then the abstract form of it. Okay, so once they get the hang of vertical subtraction, let's discuss the strategies. Again, like in addition, make sure that you first begin with manipulatives. Like I said, now here is a subtraction machine wherein the child has to push the number of balls inside to get the answer. The dough has to be smashed. The monkeys fall from the tree for the subtraction. The buttons are used, wherein you take away 2, and the tower with Lego, wherein you subtract and you see how many goes away and what's left. Bringing them from manipulatives to fingers, is another thing. So basically, like in addition, begin with manipulatives, master this concept, let them build the understanding, let them understand what subtraction is, only then move on to pictures. So when you move on to pictures, you either ask the child to draw dots and take it away. There's an interesting aid here wherein there is fish in the water and the penguin is eating the fishes. So together, first how many, then how many did the penguin eat and what's left. Again, the monkey is falling from the tree in form of image, not a concrete thing. Images, like I said, or the number of images on the worksheet, kind of images on the worksheet totally depends upon the interest and the perceptual abilities of the child. So whenever you plan a worksheet, whichever stage, perceptual abilities of the children, you have to always remember. Moving on to that, once the child has learned that, you will move on to number line. Number line, because they've used it in addition, remember there it was moving forward, here it is coming back. Okay, so start on the first number, move down as in move left on the number line, as many as the second number, and number that you land on is the answer. This takes some amount of time for the child to actually understand, learn, and then do. So what you can maybe alternatively do is that the technique that you're using, for example, if you've used number line, if your child is okay to use number line in subtraction, can get a hang of it as in going forward, moving backward, go ahead and use this. If not, use another trick here. Don't use a technique that you've used for addition, especially in the beginning, when you know you've just introduced subtraction to the child, as in counting back. So here, again, counting back, if the problem is subtracting, okay, you start with the bigger number and then you go back. That's how you reach the answer. You can also do this because number line has already given that mental calculation thing. So you can now begin with, start with number 10 in your head and then 3 numbers. So you will have 3 fingers projected, and then you will begin with counting back 9, 8, 7. Okay, subtraction by counting on is again moving forward. Now this is a bit confusing. My only request is don't use both the techniques in the beginning. Like I said, if you're using counting on in addition, use counting back in subtraction. If you're using don't use counting on if you think your child is going to get confused. Like you see here, the smaller number is in the mind and you count forward till you reach the bigger number. So 5 is in the mind and you count 6, 7, 8. Okay, so the number in your hand, you have 3 fingers and that's your answer. Use it only if you think your child can learn both. Otherwise, use one for this and one for that. Now, this is the fact family. Again, we've done it in addition. Subtraction is the same. If they've learned addition, it becomes easy. When the whole is unknown, add the parts. When the part is unknown, subtract a part from the whole and you get the other part. We've actually done this. So subtraction, but using addition. Okay, so part whole is something that they've learned there. Now that gives them introduction here to subtraction too. So 3 minus 2. So whole is 3. 2, if you take away, you have 1 left. The whole minus 1 part equals to the other part. So teach this, say this, model this through concrete objects like these, through pictures, and through a schema, a diagram like this. The missing number here. So the this is important again, because most of the time when they're doing subtraction, this is what they expected to do. Now begin with something as simple as this. Okay, the watermelon seeds. You've taught them the number bond, you've taught them part and whole. Practice. Once the child is good, move on to pictures. Maybe the child needs to understand, okay, 4 is this side, how will be they equal to if there's 1 already here? How many more will they need to make this equal? So 3 more lines will go in to balance the beam. So number bonds again. Okay, now this is something which is interesting. You can use this as puzzles also. Ask the child to make puzzles like these and see if the child is able to join them together. This is interesting. Teach them this particular chant, okay? Missing numbers at the beginning, do the inverse and you're winning. So missing number in the beginning, do the inverse. So it's minus here. If you do the inverse, as in you add, you get the missing number. Missing number in the middle, do a subtraction, solve that riddle. So the missing number is here. Do the subtraction, 35 minus 25, and you get the answer. Missing number at the end, that's the way I like it, friend. So it's simple. If the missing number is at the end, just add these 2 numbers and you get the answer. So basically, these are the equations, okay? The math fact. We know that 3 of numbers together can give you 4 math facts, right? So that is what is being applied here. Sneaky Sam, again, an interesting game. Now, Sneaky Sam is an image that you've created for a child. Maybe this can be a visual clue, a reminder that whenever he comes, he takes away something. Now, you have to find out what went missing. 5 plus something he took away, which was equal to 8. So, you know, okay, something. So when you subtract these, okay, 4 is the answer. 7 minus something he took away, which gives you 2. So do that, play such games with your children, make it interesting. Bar model, exactly the same like we did addition. Bar models help you understand subtraction problems easily. Try and use them when you're doing word problems. Fill in these gaps, okay, while you're reading out the word problems. Again, because this is very structured, it is a schema, it really goes well with children with autism. You can use them and you'll see that this makes word problems easy for them. They are able to understand, put the numbers here in the schema and get the answer. Same tricks that you've taught them there. 0 minus any number is equal to same number because 0 has no value. So you teach them these facts, they go as brain breaks and they'll be able to recollect. Subtract them, teach them if you subtract the same number, okay, a number minus the same number is always 0. So do it with 5, 10, do it with all possible numbers, do it in multiple ways. First, begin with manipulatives, give them 5, take away 5. They should see that there's nothing left because the same number is taken away. All right. Use doubles. Once you've done it with many concrete objects, then do it with pictures maybe, and then you can do it with numbers like these. So I'm just giving you strategies here. So I'm not too much, too much focusing on the steps. But remember, it's always like that. The sequence remains the same. Using doubles, so here again, 6 minus 3, 3 plus 3 is 6. So one part you've taken away, the rest is going to be same. Use addition doubles to solve subtraction doubles. Okay, so subtract with doubles here again, 2 plus 2, 4. So 4 minus 2, the answer will be 2 again. Take apart 10. I know 4 plus 6 is 10. So 10 minus 4 must be 6. Okay, so now what I'm trying to tell you here is that 10 is something which is, remember, if you think about making 10, you can actually do subtraction. So these are friends of 10. Okay, so these tricks are called as that. Like you have this here, you should know what can actually. So if you know the different ways of making 10, like we've taught them during addition, they also know that the other side. Okay, so 10 minus 1 is 9, 10 minus 9 is 1, 10 minus 2 is 8. These all are facts that they need to remember and recollect. Minus 9. Okay, so whenever they have to minus 9, it becomes a little difficult, but make it easy by telling them it is just 1 away from 10. So you can see 9, whereas you can think of 10. For example, 14 minus 9. Think of 9 as 10. 14 minus 10 will be 4 plus 1 because you've done one extra here. You have to add an extra 1 over here. So subtraction, near multiples, mental subtraction strategy. Again, remember to subtract. Now, like 9 is difficult, 11 again can be difficult for some children. So remember, if it is 11, you first take away 10. So 68 minus 11, for example, first take away 68 minus 10, which will give you 58. 58 minus 1 will make it 57. So first minus 10 and then minus 1. So see, these are tricks. It comes with practice. It may sound difficult right now because there are too many that we are discussing in the process. But when you're using one, depending on what is the number that you're subtracting, automatically you'll recollect this particular strategy. Partitioning, again, a mental math thing. So what you're trying to do here is that this is a great method for using for your place value. It chops all your numbers into hundreds, tens, and ones. Like we did the split one there. Okay, we did the expanded one there. You're doing the split one here. So for example, 35 minus 12, you first subtract the tens. So 30 and 10, you subtract, you get 20. And then 5 and 2, you subtract, you get 3. So then you add the answer and that's your final answer. So split strategy is basically you split a number into parts and then subtract each part separately. And then you, so this is useful for larger numbers, like I said. Another example here, 61 minus 34. 34 can be split into 30 and 4. So you first subtract 30 from 61, then you subtract 4 from the answer and you get the final answer. Especially even bigger number like this, 124 here. 124 can be split into 100, 20, and 4. So first hundreds are subtracted, then tens are subtracted, then ones are subtracted, and you finally get the answer. Compensation, like there we had, we have compensation here. So here you round off the number to make them more manageable, right? And then you add or subtract that was rounded off. For example, 55 minus 29, instead of 29, you make it 30, it becomes easy. You subtract 55 minus 30, you get 25. And then because you had rounded up this, you had added 1, you will also add 1 here and you will get 26 as the answer. Compensation involves deciding which number to adjust to make it easier to add or subtract. Compensate by changing the other number. So not that you have to do it with both numbers, sometimes one number, sometimes both number. Now here in this case, 73 can be made as 75, 38 can be made as 40. You have added 2 in both the places. So there's nothing in the end that you have to add. You've compensated both the numbers. So 75 minus 40 is 35, which is the answer. 73 minus 38 is 35. Regrouping. Now coming to regrouping, this is something which is difficult, and most of the time we have questions to do with regrouping. Never hurry up when it comes to regrouping. When you know your child has mastered addition and subtraction in general, only then introduce regrouping. Now there are certain tricks or songs or something like that that you can use for them to remember the rules. It's all about remembering the rules. Once the child has got the concept, okay, that you cannot take away smaller number from the bigger number through manipulatives, then you bring them to paper and you ask them to solve something like this. A song that will help them remember the rule is more on the top, no need to stop. So 9 is more than 8, you can directly subtract. More on the floor, go next door and get 10 more. So if more on the floor, you cannot take away from here. So you go to the next door, you take 10 more and you now will subtract. Number is the same, 0 is the game. So same number minus same number, 0. So 9 minus 9 is 0. So once they've learned this, give them these visual clues, prompts while they are learning. Help them remember these steps through such techniques. Once they've mastered as a skill, they will be automatically able to do it on paper without such prompts. But in the beginning, do give them these prompts. And before the prompts, give them the manipulators. Okay? There's something like this. When the big number is on the bottom, then you borrow. So BBB rule, basically, big, bottom, borrow. Another mnemonic that will help children remember when should they actually borrow and when should they not. Coming to subtraction, word problems. Now we will discuss this. Again, like addition, we have to first make sure that we have taught them the vocab. They know that take away, different, left, remain, all these words hint subtraction. Introduce them to another character, subtraction symbol here. So the example here that I've used is Linus the minus. Now whenever he comes, he takes away, he's bad, he makes a difference, he makes objects less, he makes big difference. So when you put something like this, you talk about this as a story, the children tend to remember, okay, minus is something which takes away, it subtracts. So association happens, okay? What does the symbol do? That kind of an association happens through these stories. Put them on as anchor charts on your math wall. Coins, again, like we used cubes there, this another mnemonic. You can read it, use it. It's, as a prompt, as a visual prompt, which children use while they are subtracting to understand what steps goes in while doing word problems. Yeah, cubes are here. Okay, now let's go and understand how do you actually do word problems with them. Okay, these are certain rules. First, make sure that you learn, you yourself read carefully, and you inculcate this habit in children that they have to read carefully when they are first time reading the word problem. When I say read carefully, they should understand what is the question, how should you solve it, okay? So what they can also do is maybe highlight certain important words, okay? The next thing here is that you have to help them understand, okay, what is the important number or the word. So highlight those important numbers, action words, question words, etc. Throw away what's not needed. So there are sometimes information in the word problem which isn't needed. For example, here there were these many people in the pool along with these many dogs nearby. So the dogs nearby isn't needed. You can help them chop that off. So throwing away, basically learning to filter information in their mind, maybe first doing it on paper and later in their mind. So this gives them the clarity what they need to focus on. Okay. Then showing them how to actually, so whatever technique they're using, like here to solve, show your work they're using, tally marks, they can use drawings, they can use number line, they can use a tens frame, whichever is the technique that they're using, they need to show how they've got the answer, say how they've done it, and then recheck their answer. So if it's addition, the answer has to be more. If it is subtraction, it should be less, and other way. So do this steps with them, go slow, okay? It takes time for the children to actually adapt to all these steps. Coming to the next slide. So this is something which is important, especially for teachers who've just started teaching math especially, always remember, okay, now this is basically a chart that helps you understand that, yes, there are different kind of word problems. Okay, so while you're planning your IEP maybe, or you're planning your math goal with your children, or keep such charts handy, okay, and then you can plan your word problems. For example, these are subset types. These are the main 4 subtypes. So add to, taken away, part, whole, compare. Now here, the result is unknown here, the change is unknown here, the start is unknown. So these are called as the join problems. Here, something is added, if you see, okay, during the problem, some action is added, a set is being added. Now, these are called as the separate problems. Here, an action is again involved in a form wherein something is taken away from the problem. Okay, now here there's no action, nothing is taken away or added. The only thing is, it is about looking into relationship between the quantities. So here, if you read through the problems, okay, later go back to these slides, read through the problems, you will understand what I'm saying. And the last one here is the compare problems. So here again, no action has happened. It is about looking into the relationship, looking into the sets. Okay, so these are different kind of word problems. Never introduce all together or follow any random sequence. For example, these, okay, this, and maybe this and this can be done when the child is in first grade. Okay, this, and these ones can be done when the child is in second grade. And these kind of problems need a lot of logical and critical thinking. So these should be done when the child is in third grade, or maybe towards the end of second grade. Again, these are readily available. These are certain things that you can keep in mind while you're planning your addition and subtraction word problems. Never throw random problems to children, because then the building of the word problem doesn't happen. Okay. Now coming to the summary, what you need to always remember is that extend and develop the language of addition and subtraction. Like I always say, math itself is a language. So make sure good amount of time in your class is spent in teaching math vocab to your children. Don't just introduce the concept. Use materials and models to strengthen and their understanding. So always begin with concrete to build the concept, to help them experience the concept, then move on to pictures, and then finally to the abstract, as in the numbers and the symbols. Develop fluency with addition and subtraction, fact knowledge, and mental strategies. It is difficult, and not all children learn all facts and strategies, but please introduce them as and when you feel there is a need, as and when you move on to the level of addition and subtraction that you're teaching them. The brain breaks are needed. The fluency to recall math facts are needed. So please introduce them, learn with them, teach them, and make sure that they use them. Children learn in different ways, so always provide ample of opportunities to them. Never think that, this particular method will 100% be used and it will work, because it did work with the other child. Give them variety. You don't know which child uses which technique to learn. Always make sure that the math resources, that resources help children to focus on the addition and subtraction process rather than the answer. So while you're teaching addition and subtraction, every step that the child has achieved or mastered, encourage and award the child there. So basically the child needs to be awarded for the progress. The answer may be wrong, and trust me, when you're dealing with children who have math difficulty, who have learning difficulties, you will see that answer is not something that is that comes easily. So if you wait for the answer, you will be frustrated. So the only thing here is that make sure you appreciate the process, focus on the process. The answer would definitely they'll achieve. So with this, we've come to the end of the webinar. I'm sure you will have a lot of questions. You may have a lot of doubts, but please go through the topic again, and maybe we can discuss some of the questions that you have right now.
Thank you so much, Ms. Smita, for this wonderful workshop. I'm sure the participants would agree that they have a whole lot of strategies that they can take and apply in their day-to-day life for children. So I thank you, and I thank you participants for patiently listening. So now when I'm sharing with you, you're all excited to get the event takeaways, the slide deck, and the resources that are coming along with it. The link for it is being posted in the chat box. Do check out and share with those whom you think can benefit from it. Also, I would like to reiterate the fact that if you would like to join hands with the ability community to spread awareness, you can do that in 3 ways. You could share the certificate programs and let others also receive the same benefit that you are receiving from these workshops. And you can create and share resources so that children with special needs can achieve better outcomes. You can also become an influencer. Becoming an influencer, you will help parents to become a better support to their children. So let me take you through this. Research has shown that as parents become more involved and empowered in the special education process, the outcomes for students improve. And with this in mind, we have come up with the way in which we can raise parents' awareness. And a parent who understands how to help a child can make a huge difference to the child's progress. And one of the most effective things that we can do as a community is to help parents become more aware and engaged in the child's progress. We have come up with the video series, Understanding Why Your Child is Not Doing Well Academically. It's a series of 5 short videos that will give parents insight into how they can support their children with academic challenges better. And to know that, here's a trailer that will give you a glimpse into what this comprises of.
When your child is not doing well academically, blaming the child, the school, or yourself is not the best answer. It is important to understand why. It will take some effort to identify why your child is struggling academically. Once you know why, it will be much easier to help your child. With persistent effort over time, most difficulties could be overcome to a great extent. Learn what the challenges are and how you could be the best answer to your child's difficulties. Sign up for the video series. In less than 20 minutes, you will have a better awareness of how you could help your child.
Fantastic, isn't it? There are times where parents get stuck as to what do we do when a child is facing an academic difficulty. You, as parents, teachers, and special educators, can become an influencer. You could help the parents know, to understand, and become a positive force in the child's life. This video series that we have come up with is one way of raising awareness to parents on why their children are facing academic challenges and the role that they could play to support their child. So now you could sign up as an influencer and share these videos with the parents. So I could take you through how you could become an influencer. It's a simple 3-step process where you have to sign up, personalize, and run your first campaign where you could share links with the parents to view your series. Taking you through that, now the link will be shared in the chat box and you could click on the link to explore and I will take you through. The link is being shared in the chat box and once you receive the link, you can click on the link. After you click on the link, you will land to a page that will give you information about this entire series. What are the videos that it comprises of? Who are the expert advisors? The program details and how you could sign up. So once you scroll, you will come to this button of Start Your Awareness Campaign. So once you come to Start Your Awareness Campaign over here, let me take you a little back. So over here, Start Your Awareness Campaign. You could click on it, and the moment you click on it, you will get to this dialog block that is sign up to raise awareness. And when you click on it, you could enter your login credentials and then accept the terms and conditions and click on Start Your Awareness Campaign. Once you do that, you could personalize your page. In personalization, you could add in your name, your role, your city, and your country. It's optional to add in your photo, name of organization, and the organizational logo. For now, you could just add in your name and then click on Save. Let me show you how. And then later you could personalize it in detail as you like to. As you see here, the photo is there, the name, your role, your designation. Which city are you from? All those details could be filled in by you. It's not compulsory to add in your organizational logo. You can for now add in your name and click on save. So once you click on save, let me show you here, you are saving the settings. So once you click on save, you will be saving your name like you saw here. And after that, you could go on to the third step where you'll be ready to launch your awareness campaign. So if you're happy with your changes, you've entered your name, do click on save, and you could move ahead and click on start your awareness campaign after saving the changes. That brings you to the third step. That is, you can run your first campaign. You can share the link that comes to you, that's your unique link, and you could share it via WhatsApp, Facebook, and other means. So if you look here, once you click on start your campaign, you will be getting your unique link. You can copy this link and paste it to your people or your parent circle. You could also invite them via WhatsApp or Facebook to view these video series. And while you share this link via WhatsApp, Facebook, or by copying the link, you might be wondering, how does it look to the parents? So let me show you how does it look to the parents as well. So once your unique link is shared on WhatsApp, this is how, when a parent clicks on the link, it will look like. It will have the heading stating invited by, like Swati was creating the profile, the link when clicked will bring to it as invited by Swati ability, and then when parents land on this, they are supposed to click on the register button. And in this page, they can explore about what this program is, what are the various steps involved, what are the program benefits, and the expert advisors. So they can go through, read about the program, and then click on register to know about the video series and also view it. So once they click on it, they can view the video series. And to unlock each video, they have to view the previous video. And that is where brings, and the 5 videos when they watch, it brings them to the completion of the entire video series. Now, when you share links, you might also be wondering how many parents have signed up, what is it, that which stage are they at the video completion. We have that for you as well. So in that, you have your influencer dashboard. In the dashboard, you need to come to your profile and click on this hamburger. Once you click on this hamburger, you have the option of program. You click on program and it lands you to your onto your influencer dashboard, where you could know how many parents have registered, how many steps completed, and how many people have completed the entire program series. So you can land onto the influencer dashboard to know about how many parents have viewed your invite. And now, if you wish to see the video series, I would be inviting you via my link to view the video series, and that link will now be shared in the chat box, and you can also view the video series that is created based on understanding why your child is not doing well academically. So if you wish to stay connected, support us being an influencer, you can join our WhatsApp and Facebook influencer groups, and the links of those are also being shared in the chat box, and you can join and stay connected and create an impact to the parent community. Let me also update you about the upcoming events. The links of it would be shared in the chat box, and you can share it with anyone who can benefit from it. So on the 5th of May, we have How to Help Children Overcome Academic Stress. That is by Miss Lama Majaj. And on the 12th of May, we have Improving Arithmetic Skills in Children with Special Needs by Mrs. Smita Tripathi. Do forward the links to others who can benefit from it. So now we'll be moving on to the Q&A. Are you ready, Ms. Smita, for the first question?
Yes, Shivam.
Great. The first question is from Miss Angelica, who wants to know what are the ways when we have to teach children with special needs, When we have to introduce the concept of addition and subtraction, what is it that we start off with first?
Yeah. So, like we saw in the webinar, I'll just take a quick recap of that. When you're planning to teach addition and subtraction, begin with the prerequisites, make the base strong. So, teach them the concepts like counting, number counting, okay, skip counting, +1, -1, adding up to 10, place value, most important. So, once you've made the base strong, along with the prerequisites, you can also begin teaching them strategies and math facts. Like we discussed, math facts will help them if quickly apply them and make addition and subtraction easy for them. Also give them or teach them supportive methods, because we're talking about children with special needs. Supportive methods are a big help, like introduce them to counting with fingers, tally marks, drawings or dots. So this will be something that is handy, which even if you're not using manipulative, something which is there with them as a big support, and they can use them for addition. Having said that, while you've done all of these, never ever forget that introduce the concept with manipulatives. Like I'm saying right from the beginning of the webinar, manipulatives will only make the concept go down with them, understand, and then application comes. Unless and until you've understood, you can never apply, right? So begin with manipulatives and then take them through simple addition, then move on to simple subtraction, and then increase the level of difficulty.
Thank you so much. Starting off with the pre-math concepts, taking it one step at a time will be beneficial. Now we have a question by most of the participants from Deepa, Arlene, and others asking as to what could be the reason that most students are not wanting to learn math or are actually fearing math.
Uh, this is a good question. Till date, I'm sure, every time I meet a child, I have to actually start from the beginning as to understand what can be the reason for this particular child for not liking math or unable to do math. The reasons more or less are same, but every child has a reason. Sometimes it's the abstract nature of the math, because math is abstract. Maybe the child has poor IQ, poor cognitive skills, poor number sense sometimes is a big reason. There's a lot of gap in the math of a particular grade of a child because the child has not mastered number sense in the beginning. So that becomes a main reason. Sometimes it's a lot of pressure, negativity. When I say negativity, what happens is if I, as an educator, I don't like math, maybe through my actions, I convey to the child that math isn't easy, it's difficult. So your attitude matters. Sometimes you've passed it on to the children. That can be a reason. Sometimes poor curriculum, the teaching techniques have not been good, because of it the child has not mastered concepts. The child knows they are unable to perform. Sometimes it's anxiety to do with math. They fear numbers because the application is something that they are expected to without being taught what actually the numbers mean, what quantity is like. So different children have different reasons. You as educators and parents are the best ones to understand. With stress, nobody can learn, not just math, any subject or any skill for that matter. So don't put stress on children. Make it interesting. Hands-on techniques are the best techniques. Use them. That's what we can do, and then see if we can actually make the dislike less, for the child, or maybe help them start liking math.
Identifying the cause is extremely important, and coming up with innovative strategies so they start liking it is important. Now, we have a question from Aditya Shah, ma'am, who wants to understand that you've spoken a lot of strategies like how can we improve the addition and subtraction skills. Using different strategies will be confusing for the child.
Yes, like I said, even while I was talking about these strategies, trust me, because you've seen all of them together, it's confusing. But when you introduce a particular problem, like if you're doing addition of numbers closer to 10, automatically, if you've spoken or taught them the make 10 strategy, or friends with 10, so child will be able to recollect, child will be able to apply that here. Don't get, if the child is able to do it without strategies, which is very rare. I'm telling you, even we as adults, there are a lot of times when we've tried using mental math, we've used tricks in our mind, we've used shortcuts. When I say shortcuts, I'm saying math facts. Like instead of adding numbers directly, we've added a closer number, like we've added 10 first and then the left number. So strategies always help, but when to use, how to introduce, and practicing the strategy, okay, practicing number facts, uh, bringing on using activities, tricks, and games wherein the child can recollect. You have to build the fluency. The automatic thing has to happen. So if you worked on that, you will see that yes, while you give them a math problem, which can be solved using one of the trick or the strategy, like I said, add, doubles, when you're subtracting the same number, when you have to add zero, when you have to, adding number closer to 10, they will recollect and they'll be able to apply. So don't worry, don't teach them all together. Teach it only when you've reached that level. Like if you're doing simple numbers, use strategies that are needed then. When you're moving on to double digit, or maybe you're teaching them to add in tens, only then you introduce them to that particular strategy which is related, and then see if they can apply.
Choosing the strategy as per the level of the child will be very helpful. Moving on to the next question. This is by Samuel. He states that children usually find it difficult to understand regrouping of addition and subtraction. Can you suggest strategies on how to help them understand better?
Regrouping is difficult, especially in the beginning. Once they've mastered, it's something that naturally and automatically comes to them. So regrouping, you first teach them the terms like we do for other concepts. Help them understand what borrow is, what carryover is. So in addition, it's carryover. In subtraction, it's borrow. So once you've used these terms otherwise, and then slowly use the same term when you're doing numbers and regrouping with them, they'll be comfortable with the term. They at least know what it means. It's like a language, okay? So they'll know what it means and they will automatically apply while they're doing it. Another trick is not trick, but yes, what the base building before you teach regrouping. So they should be comfortable with place value, okay, count in tens and count till 10. If they know this, they understand the group, counting in groups of 10. Trust me, regrouping is going to be easy. So first work on this, then come to regrouping. So base is done, the language is done, and the next thing that you will do is hands-on activities. Okay, so teaching aids. So what comes to your rescue is the base 10 blocks. You can also use expanded form, using expanded form like we discussed. So if they are comfortable with base 10 blocks, they can actually draw images as units, rods, flats, and they can actually do the regrouping. Okay, and then you can also use those chants that we had discussed, like, if more on the top, no need to stop, more on the floor, go next door, the number is the same, zero is the game. So these are certain tricks and strategies and technique, because we know, maybe we think, why do we even use that and waste time? But trust me, for a child who's stuck, okay, who don't know what to do when they face regrouping, when they're actually solving, these strategies come as rescue. So they are able to recollect, remember, and apply. So
thank you so much, ma'am. We'll take the last question for today. The last question for today is from Srimati Swavna Devi, who wants to know what are the strategies that can be used with children to help them understand the concept of problem solving in arithmetic, especially when they have poor word identification.
Okay, you said poor word identification, and what was the previous thing?
How can they solve, word problem solving when they have poor word identification?
Sure, Shivani. So problem solving can be as word problems. I'm assuming that to be here. And word difficulty is like language difficulty, which I think you mean. So here, okay, so we are assuming we're teaching problem solving to a child who has language difficulty. So this is like too much of difficulty together. I'm sure it's not going to be easy. Have patience. But yes, what you can actually do here is first get them used to the language. So when I say language, because we know the child is finding it anyways as language concern. So it's not easy for a child to remember what word means what. The association is going to take time. But whatever techniques you use, for example, for language building otherwise, like you can use flashcards, you can use tracing on a sand, or you can use puzzles wherein you associate this plus this, so use techniques that you can first to make the word familiar so that the child gets hang of it. The most important part here, while you're trying to do word problems with them, with children who have language difficulty, the way you frame your questions, okay, you have to customize. So start with questions that are simple. They don't use too many words. Even if they use, you have to give them a ready schema wherein they can apply, okay, like, this particular word means this. So do this more often with them. They should get practice of this. Don't use indirect speech. Use active sentences more than passive. For example, John bought pencils. So it shouldn't be the pencils were bought by John. See, because here we are dealing with language difficulty. So make the language of the problems as simple as you can. You can then you've less number of words, focus, help them understand how to, filter words that are not needed. It takes time, but eventually when you begin with something like this, they get the flow of it. They develop the skill to identify the numbers, the action words, the question words, also associate the word with what it means, the action that's needed, and then maybe slowly take it ahead. So customize the word problems for them. Math is like English. Like I said, the numbers are the nouns and the symbols are the verbs. So get them hang of what symbol means what is the action that is expected.
Building on the vocabulary, continuous exposure, and using these strategies one at a time will definitely help the child to solve word problems. Thank you so much, Ms. Smita, for patiently answering the queries from our participants. And I would like to thank the participants also for being patient and active listeners. I would like to inform you all that when I was taking you through the parent awareness series, if you have not followed me, the link would again be shared, and also the handout link where you know how you can register up as an influencer, a step-by-step guide would also be shared in the chat box. You can view that and sign up as an influencer and invite parents to view the parent awareness series. Thank you so much, all of you. Smita ma'am, your words for our audience before the closing.
Thank you to all the participants for patiently going through these strategies. My only request is that please go through the slides once more to get clarity, and do Google more if you like any of these strategy, and if you think any of these strategies is working well with the child. The only last thing that I want to say, everybody can here genuinely use the strategies, be excellent at it. If you know what your child is interested in. So use the interest of the child, the strength of the child, go ahead, use these strategies, you will definitely achieve success.
Thank you so much, Ms. Smita. Now, I would like to inform you all also about the upcoming events where you could book your slots for. You can check out the links in the chat box and register for them. On the 5th of May, we have How to Help Children Overcome Academic Stress by Ms. Lama Majaj. And on 12th of May, we have a continuation of this, Improving Arithmetic Skills in Children with Special Needs, where multiplication and division strategies would be dealt by Mrs. Smita Tripathi. They'll be done at 12:30 p.m. Nigeria time, 4:30 p.m. India time, and 7 p.m. Singapore and Philippines time. Hope to see you all there. Do forward the links to others who can benefit from them. Until we see you all again, it's a big bye from Team Ability. Have a wonderful day ahead.